Okay, today is lesson 5 out of Unit 11. It's called Exponential Functions, and we're just doing some review here. And I'm having students try this one, and I'm going to see if they've got it. I'll pause for a second while I give them their feedback. Okay. So, no, I think I was pointing at somebody else when I said that, but I don't know. I could be wrong. So I'm adding 1 to both sides, and then I have x to the 2/3 is equal to 1, and then you all knew, I think, to put it to the 3/2 power, but I think a lot of you forgot that you're putting it to an even root, which causes you to have absolute value of x is square root of 1 is 1, 1 to the 3rd is 1. Then it's two things, plus and minus 1. Okay, good. That's a really common mistake, and again, I'm trying to keep on pounding you with it over and over again so that hopefully you won't make that mistake on tests. Yes? Okay, first of all, it wouldn't be 0 to the 3/2 because this has to be done first. Why? Because we got to get the clump alone. Otherwise, you're trying to put this whole thing to the 3/2, and that's not going to work. All right, so you got to get that clump alone first. Now, once the clump's alone like this, then you put it to the 3/2 power. Okay, moving on to the next one. This one, you need common bases. Get the bases the same. And let me ask you, is this one of those exponentials or not? Is this one of the exponential kind of problems? Finish the sentence. Exponentials have a what in the what? X in the exponent. So this is an exponential. All right. Yes, you can use all kinds of fancy bases for this, but what's the simple base you could use? 3. And if you change this 1/9 into a 3, you lie, because 3 is not the same as 1/9. But you could change it into 3 to the -2, because you want to square it and flip it, right, to make it 1/9. So now 3 to the 3x is equal to 3 to the -2, and since the bases are the same, we can ignore them, and that has to equal that. 3x has to equal -2, so x must equal -2/3. Raise your hand if you had that one right. Good. Now, just check back quick. Is there any chance that we should have, did we ever square root both sides? We did not square root both sides. Therefore, this is right. What if we had square rooted both sides? We would have to do what? The plus and minus thing. Remember, if you square root both sides, if you do this thing, you know, where this is an even power on the bottom or whatever. All right, so back to this one. You got to simplify this down, and notice it says solve for x. That means you should say x equals, and then it might have a y in your answer, and it's okay if it does. Just get the x alone. I'll pause for a second while I try that one. Okay, so here's where we're at. This 3 and this 12 can simplify, and I like to do that by, if you can factor, you should. I change that 12 into 3 times 4, and then this cancels this. Yay. Now I'm going to do my x's. These aren't happy where they are, they go down. And these aren't happy where they are, they go up. So when they're going down and going up, it's probably simplest to just subtract and go, okay, -3 minus -5. That makes -3 plus 5, which makes +2, which means the x's are a positive exponent, so they're on the top and squared. If I had rearranged them and put 5 up to the top and 3 down to the bottom and then some cancel, you'd still have 2 left on top. Either way you want to think of it. There's x squared on top. Raise your hand if you had your x squareds on the top. Good. Then the y is still on the bottom. There's no reason to move it. It's not to a negative power or anything, and it's just a y down there. So after those 3 cancels, I have x squared over 4y is equal to 2. Then if you want the x's alone, you multiply by 4y on both sides. That's getting this out of here. And now I have x squared equals 2 times 4y, which makes 8y. And then I take the square root of both sides. Does that trigger something? Yes, absolute value of x. And then that's plus and minus. And square root of 8y is fine to leave that way. If you want to break up the square root of 8 into square root of 4 and square root of 2, you could. And you'd have x equals plus and minus. If this is square root 4 and square root 2 and then square root y, that part is 2. 2 square root of 2y. There's your final answer. Now, I'd be fine with this one also. Raise your hand if you had one of those two answers. Okay, good. Now, we really haven't done anything new here. Do you remember this? Do you remember me telling you to watch out for this kind? Because sometimes when you get to the end and you get the answer, it's called what? Extraneous. Is that a guarantee? No. Sometimes it will turn out to fail. Other times it will work. Would you double check this one? Solve it by squaring both sides first. You get an answer when it's all done being solved. And then sometimes the answer works when you plug it back in. But sometimes it doesn't. I'm going to pause for a second while you try this. And I'd like you to check this time with the person that I pair you with. Okay, so you should have squared both sides. You can get x minus 4 equals 5x plus 1. It's really simple to start with. Still not too bad. Got variables on both sides. Take away an x from both sides. And I got negative 4 equals 4x plus 1. Now I'm going to get the x's alone, so subtracting 1. Negative 5 equals 4x. Then I'm dividing by 4 on both sides. I got x alone. Cool, and it's that. Now, do I know for sure if that works or not until I look? No, it might work, might not work. Double checking it, I put in a negative 5/4 right there, and right away I see something weird. Because it was a negative, and it's subtracting, it's going to make it even more negative, and I have the square root of a negative. Instantly, it's over with. You can't have the square root of a negative, and therefore your answer was extraneous. So you should have crossed it off. First of all, you can't just say, see, some kids get stuck and they're like, I don't know what to do, so I'll just write extraneous. That doesn't work. You have to identify what the answer is, which is that, and then you cross it off and say ext for the full credit. Does that make sense? Because it's an answer. It doesn't actually work, and that's what extraneous means. Okay, moving on. This one, let's save you some time. The first step would have been what? Add 5. Then the second step would be to put it to the power of what? And as soon as you do that, you're creating what? A square root on both sides, and therefore the answer would have been plus and minus. All right, now let's just do this part. Absolute value of x plus 2, do you get what just happened there? Equals 4th root of 16, which is 2. 2 to the 3rd is 8. I just crunched a bunch of numbers there, but do you know what to do from here? Go ahead. It's one of those top 20 skills that I practiced with my kids for a semester. I want to see if everybody knows how to do this. The answer is not plus and minus 8. Pause for a second while we see if he's right. All right. Get rid of the suspense here. I hope you know you split these into 2 equations. You make them identical, which seems like madness. X plus 2 equals 8 and x plus 2 equals 8. And it is madness if you did the exact same thing twice. So what's different about the second one? It's negative 8. What's happening here is what's underneath the scribble is either 8 or negative 8, and it'll work either way, right? That's why we write it once with positive 8 and once with negative 8. And from there, you solve your 2 little equations, and this one comes out to x equals negative 10. You were off just a smidge there. And then add 2 to both. X equals, subtract 2. Thank you. I was like, wait a minute, he's right. He can't be right. 6. There we go. 6 and negative 10 are my 2 answers. Now, if I was concerned about this, I'd go back and check them both. But do you remember that it's the kind that start with a square root in them that I'm nervous about? Does this have a square root in it in the first place? No. It has a 3rd root in it in the first place, so I'm not that worried about this one. All right. If I wanted to be sure, though, I mean, hey, it's your test, and you only get, like, let's say that there's 12 questions on the test, a bunch of R2s and some R3s. If you only have 12 things to check, why don't you just check them all? And you'll know if you're right. If you're wrong, you can start over again. Wouldn't it be handy if I came by and said, hey, your number 5 is wrong? That'd be a huge hint. Wouldn't it be like unfair for me to tell him that his number 5 is wrong and he gets to fix it? You can do that for yourself by checking your answers. So they don't actually work when you stick them back in here. Stick in a 6 here, see if it really works. Stick in a negative 10 here, see if it really works. All right, that is a big advantage, so I encourage you to do it. All right, I want to get to the new stuff. This is the stuff we just did yesterday. And you could start this by getting by multiplying both sides by a to the x. But let me tell you a different way. Do you get that on this kind you subtract these two? Do you get how that means this is a to the negative 4 minus x equals a to the 10? That's just copied down. Look at that thoroughly, what I just did there. Now, why was that smart? Because now I have the same what? Base. If I have the same base, then all I have to do is set that equal to that. That's the fast way to do this problem. Multiplying by a to the x would have worked. It would have been legal. But this is a faster way. Because once these bases are the same, the two things that are circled have to equal each other, and it's a simple little algebra equation. Yes, ma'am? Okay, if this had been a square root, we should have checked to see if it's extraneous, yes. And since the root part in the original problem was a 3, it's not a square root problem. And therefore, I'm not likely to have it crash. So I've told you to profile the ones that have square roots in them. Because if they're like this to start the problem, or which is the same thing as like this, if they start off with a square root in the problem, then sometimes when you stick your answer in, you're doing a square root of a negative and it won't be possible. So, all right, back to this one. In your head, should be able to go boom, 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 3 little steps, and you got an answer. And the number's like 1/7 or something. Figure it out. It's a fraction. Compare it with the kid next to you. But maybe wait to see if they're done first, because if you just show them the answer, then they're like, oh, I know the answer. What on earth am I doing? I'm dividing it up into 3 steps. First step is to take the what? Square root. Square root of 25 is? And then I take that 5 and I put it to the third, which is answer of 125. And then I take the 125 and I put it to the negative 1 over 125. Because 125 had a 1 under it. Oopsie. 125 had a 1 under it in the first place, and this means flip it. It becomes 1 over 125. Okay, now, here's the new thing for today. We needed to do a lot of review because there was a lot of little things to learn and things that you could easily get trapped on the test. But here's the new thing. Do you remember these? It had a starting value of what? 500. Yeah, that's called the what? Nope. The thing I circled there, that's a domain. Good. We usually pretty much ignore that. And we started with 500, and then what's this doing? Increasing by what percent? 25%. Notice there's no factor for monthly or anything. It's not quarterly, so therefore it must be yearly. 25% increase starting with 500. Okay, now it'd be 500 rabbits, and they're going to grow by 25% per year. And with rabbits, it might be 25% per 3 months. It's crazy. They just could grow insanely fast. They just get limited by the fact that everything eats rabbits. They're like the happy meal of the great outdoors. All right. So anyway, this could be rewritten from this. Do you get that this actually is doing the same thing, and it's an exponential? This whole thing you learned was called recursive equations, and they're important. They're on the ACT. It's one of the topics that the ACT can have, and it's also one of the topics that the Minnesota Comprehensive Assessment, MCAs, have had on them for years to see, like, are you really decent at math? That's one of the topics they want you to know is that. But now we're moving into exponentials where there's an x in the exponent, and do you get that we could put our starting amount here? And what we want it to grow by after the 1. You get how that's just pretty much these two added together, 1.25. And then this is how many times you want it to multiply, or how many years do you want it to grow for. So if I wanted this to grow for 3 years, I'd have to do a kind of complicated process with my calculator, or if I wanted it to go 3 years, I just have to stick a 3 right there. You see how quick that is? I know what you're saying. You're saying to yourself, why did I have to learn that other style? Because it's a topic, again, that is expected in math to be able to handle. This was complicated, isn't it? This is not complicated. We needed you to be able to handle complicated notations. And this is one of the few notations for math that everybody agrees upon is something that is worth young kids knowing how to do. It's a complicated other notation for math. But this will solve your problem way faster and easier. All right, let's go back to what it was. This was what we started with, right? This is what we started with. This is the growth part, and this is however many years it is. And then the only other thing that is, what if they give you the ending answer? Do you get this is the ending answer? So this is start. This is end, as in the final answer, like how many you're going to have after they grow 25%, 4 or 5 years or whatever. This is the end answer. Start, end, and growth. Throw an x in the exponent. There, I've taught you the new stuff. Yes. I know you may not be ready yet, but that's the first shot at it. Yes?
They like plug in the final answer and then you just find the exponent?
Exactly. Let's say that they said, we had 500 weasels in the state, and it grew to 1,000 weasels. We know that they were growing by 25%. Then you could solve for how many years did it take. Like x is how many years it took, if it grows by 25%, for the weasels to go from 500 to 1,000. Right now, sadly, we have a situation with moose that just keeps getting worse and worse and worse. The moose population went down another like 10 or 20% this last year. And it's really sad because they're one of our kind of our signature things for northern Minnesota is the moose. And we still have moose, but it's dropping dramatically. They are figuring that the main thing that's getting them is, you'd think it'd be like wolves. Well, actually, wolves do eat them, but wolves usually can only get them once they're sick. Because the wolves, if a moose is like totally strong and healthy, they can fight off wolves. You might not think so, but they're strong and they can kick, and they will kick. You know, you get a moose kicking you as a dog, basically, as a wolf, and it can kill you just with one kick. So they can usually handle themselves, but if they get sick, then a wolf pack can take them down. So what are they getting sick from? They think that there's this, well, they know, they've seen that there's this bug that is getting them. It's kind of like a tick. So basically, like, they get infested with a whole bunch of these ticks. And, you know, if you could just pull it off yourself, if you had opposable thumbs, it'd be different. But they have hooves, and they can't, like, reach all the spots on them. And it's really pretty awful. It's a terrible way. Can you imagine you dying from being eaten by ticks? You know, like you couldn't get them off yourself? You'd be scraping yourself on stuff trying to get them off, and then you get infected from it, and nasty. Okay, anyway, our moose population is going down, so I'm giving you a problem like that. Let's say that we have 2,000 moose in Minnesota, and they're dropping by, let's say, 20% per year. Can you finish the exponential equation that you could write for that? See if you can do it. Start with 2,000. 20% per year. You go 1 minus 0.20 to the x? Raise your hand if you did that right. Okay, good. Now, what if I instead change the problem to, I know that the moose population is going to turn a corner this year, and they're going to grow by 5%. If they grow by 5%, get what I just did there? My question is, what if I say, how long till the moose population doubles? What do I do? Do I put in numbers for X? Keep guessing and checking until I get the answer? No. If I want the moose population to double, what is double? 4,000, where should that go? Exactly, so you put in 4,000 here. And then, how do I solve it? How do I get the clump alone? Divide by 2,000, very good. Cancels that. 4,000 divided by 2,000 is 2, 1.05 to the x. And then we still have to solve for this. Now at this point, I can't make those bases the same, and so therefore this one's a tricky one. But if I had to, there's one way that I've tried to tell you guys over and over to see if it would stick. Another way you can solve any equation. You got it, good. You graph both sides and see where they what? Where they cross. Okay, graph both sides, see where they cross. That works for anything. Again, this is like the fourth time, if you've been with me since the beginning of the year, fourth unique kind of problem where I've showed you, you could just graph both sides, see where they cross. Okay, but there's also something you can do called logs, and you're going to learn that next. That's our next chapter that we teach you. For right now, you don't have to know logs. Yes? Well, it's kind of like this. Could I write this as a 1.05? Sure. And yes, you're asking, could I have written that other one as 1 minus the 20 means 0.80? But I like to leave it like this because it shows me what the growth or decay rate is. So I prefer, like in this, now let's go back to this one. When we did have decay, let's say it was like that. I prefer to leave it like that because I can see, look, falling by 80%. If I subtract, or if it was a 0.2, now it would be falling by 20%. If I subtract them and actually put a 0.8 in there, it's really hard to tell what the growth was or the decay was because it looks like it's 80% growth and it's not. And then it might be like, whoa, is it 80% decay? It's not. That's why I think it's better to leave it as 1 plus or 1 minus something. All right, for this one, the yellow slide, get there, please. Rewrite the recursive formula on the left in an exponential on the right. So in other words, see if you can take this stuff and make it into one of these kind of equations. Try it right now. I'll pause, we'll give that a shot. Okay, what did you say? Yep. Y equals 75 times you got it. That's all there is to it. And what if they had told me the ending value? Like what it was going to all result to? Yeah, you'd put it right there. Good. Let's say that the 75 was going to grow to 150, it's doubling itself. You'd put a 150 right here, and then you would solve, and you could find x. All right, moving on. This is calculator allowed. Would you grab a graphing calculator? Everybody grab a graphing calculator. I'll pause while you do that. Okay, when I hit my y equals on my calculator, it puts me in this weird mode from the last time where we were doing sequences. Do you know how to fix that? Under what? Mode. If you haven't already fixed this, go into mode and then go down, and instead of SEQ, which stands for sequence, we need to be in function mode. Some of you, that's abbreviated as func. So yes, this, if we put it uptown, would be us going into uptown func mode. All right, second quit. Okay, so now I am in normal y equals mode again. Please do that if you haven't already. It's under mode. Okay, so I'm going to set this aside for just a second and read about my cockroaches here. They're taking over his house. He takes a census and determines he got a population of 18. He reads up and determines that it will grow by 15% per week. Write an exponential function in this form, and we won't need the calc yet, but would you just write me the equation for this puppy? Notice they're exponentials. So there's a what in the what? X in the exponent. Very good. Y equals 18, 1 plus 15 to the X. I made a classic mistake in there. What'd I do? 15 should be 0.15. Very good. Now is it right? Except I'm missing one little thing. What does it say in the directions? Use that to determine how many there will be in 3 weeks. So therefore I should put the 3 right here. True or false? False. False. Because that's where the final number of cockroaches go. This is where we should put the 3 in for the X. And couldn't I just like multiply that all out and get the answer? Yeah, and that's what the calculator would do for you. So everybody right now, if you want to, you don't have to graph this. You can just type this into the normal part of your calculator. Type in all that right there. And make sure you put in X is 3, and you'll get an answer. Yes, once you've put that all in properly, then you just hit enter. What did you get? Anybody verify 27.7? All right, cool. So what does that mean? That means 3 weeks from now, there'll be 27.7 cockroaches. You get how that's an estimate? It's about 28 cockroaches. Yes? It's a good question. I would have said is to just say 27.7 and understand it's an average. It's kind of like saying in this community, people have 2.3 kids on average. We don't expect people with a 0.3 of a kid running around in their house. We get that that's a decimal. Okay, but if you're going to round it, you're right. The rounding down to be a better choice than rounding up. All right. Yeah, they would just be from the knees down. Okay. Say that again. Yep. For this, so far, we've only been doing this in years, and they just are going to work out really clean and nice, and you don't have to worry about it. When they get complicated, we'll talk about it. All right. Sally Mae's going to start brushing her teeth. Dennis told her that she needs to brush the teeth that she wants to keep for the long run, so she starts brushing for 5 minutes. If she continues increase her brushing time by 5% per day, by the way, she really shouldn't, because actually you can brush too much too. If you brush your teeth too much, you actually rub the gums right off your teeth. Isn't that disgusting? So yeah, you can brush too much. Now, a happy medium is to do just right, which is some brushing every day. In fact, twice a day, even dreamily 3 times a day, although I don't think too many of you probably pack a toothbrush and brush after lunch. But anyway, so back to, I'm just wanting to point out that this is not suggesting that the ideal world is you brush for 20 minutes every day. That's insane. In fact, I've got one of those electric toothbrushes, and it shuts off after like 3 minutes because they know that if you keep brushing your teeth for too long, it's actually bad for you. So anyway, but by the way, just a little plug for electric toothbrushes. They get your teeth really clean, like way better than normal toothbrushes. And it does shut off too, which means you know how long to brush for. Like you're not brushing like, oh, should I keep brushing or should I keep? It just shuts off. You just keep going until it shuts off. And that's simple. All right. Anyway, if you're going to do this problem, I'm hoping you're thinking about setting up an equation that starts with y equals and then has some starting amount, and then you're going to do 1 plus or 1 minus something, and then it's to the x. Does that all make sense? All right. See if you can set this thing up and put all the things in the right spots for this problem. I'll pause for a second while you think that through. Time. Okay, so she starts, she's increasing by 5% per day, 0.05, and 12 days, the 12 goes here because that's not what the time is that she wants to. She started for 5 minutes, so we put a 5 right there. So there is your problem. You just have to type that in. The calculator will give you the answer. Tonight, since I didn't give you too much time to work, your assignment is the evens. Again, just evens on tonight's homework. Even problems, and if there's letters, even letters. Have a great day.